Hello guys, welcome back to a new CTF video. Today we have a pawn category CTF with the name racecar. So this is a challenge description. Did you know that racecar spelled backwards is racecar? Well, now that you know everything about racing, win this race and get the flag. So I already got the file here, and to start with we will first see what kind of file is it. Let me make full screen and let's see what we are dealing with. So 32-bit executable. Let's give permissions to this file, racecar, and let's run it. Okay, so we have this interface here, finish to cars. Okay, let's input something here, nickname. Okay, welcome, your name is, but everybody calls you current coin 69. Okay, so we have a menu here and it asks us for an input. So let's go 1. Okay, it displays some random bytes here. I don't know what the what the problem is. So okay, so let's go to car selection, select a car and select a circuit, a race, select a race. Okay, let's select a race and you lost the race and all your coins. Okay, so basically we need to win the race. So let's try run some strings on the file. Let's see if we can find something directly. So okay, waiting. Flag.txt is the file. Okay, we will connect to a remote server. We see here we need to start the instance, but we will first make it locally and then go solve it remotely. So we have to insert our data. Okay, car info, and nothing really useful here. So let's run redirect on this file and see if we can reverse it from here. So race car, okay, and let's go directly into the main function. Okay. So what happens here? It calls the setup, it calls the banner, and it calls the info. Okay, the banner is that finish something, drawing. When we start, info and setup. I don't think this should really interest us. So, okay, it calls menu and then it compares what is in AEX. So basically, what menu returns, it's compared to 1 or 2. So as we've seen, there are those options, car info and car menu, returned here. So it jumps to car info or car menu here. And yeah, you can see that it's jump if equal 0x 14.2b, and it jumps to 14.2b, which is here, called system car info, and if it's 2, it jumps to 0x 1432. So it goes here, and then it calls car menu. So let's go to car menu and see if we have something there. So sim that car menu, and car menu should show us the menu which lets us pick a car. Oh, okay, it's a very big function. So what this does is declare some variables. Okay, it puts time. Okay, so it gives the current time basically here. It then generates random numbers using a seed. GFFF, I don't know what this does. So okay, it's kind of a big function. So here it opens a file. Okay, it opens a file. It reads from the file here. Okay, but let's see what the logic really is inside this. I can really figure out from here. It calls random multiple times, as we can see, and it makes some comparisons here, but it's not very clear. So it's better. We are gonna use another tool for this. So let's go into Ghidra and let's analyze the binary of Ghidra because it's a little bit more verbose for our scope, and I think we'll have better informations from this. So let's import file, but I don't know if we have it. Okay, we have it here, race. Let it import. Okay, it's already set up and it will be imported. Okay, some informations here, nothing really useful. So okay, we will open Ghidra. Let's wait a little bit. Okay, let's analyze it. I think this is not needed. Let's go aggressive. Okay. Let's wait for the analyze and then we'll proceed looking into the functions. The CD compiler, now it checks for strings. We already run strings and saw that there's nothing useful. So into functions, I think we can already go into. Okay, so main, it's set up an ivar1. It calls setup banner as info as we saw, and while check is different from 0, ivar2 is equal to menu. It goes into menu, and menu returns 1 or 2 as we already knew from the previous reverse. And this calls car info, which I don't think is really useful, and this calls car menu, which we'll go right into. Yeah, many variables are declared. Let's see. Okay, this reads an int here, 1 or 2. Okay, invalid choice. While, okay, so here we need to give 1 or 2 as input, and then, yeah, it calls another function race type, which returns its value into ivar2. So what this does is to also read 1 or 2 to select the race. So basically, if we go back, we can see that first we are selecting the car here, and second we are selecting the race type. It creates a seed and creates an srun with the seed of, if the current time was the seed. So next, what it does here, it creates some random values and stores the last okay, so it stores the last digit in ivar2 and the last 2 digits in ivar3. If this goes through, and if this goes through, it does the opposite. However, here in the else, it stores in both of the variables the last 2 digits. And if you go here, while true, so it goes and it says waiting for the race to finish. If this is lower than this, then it prints again. Okay, this is strange. We'll look down. So if this goes through, then we won the race. Okay, so we need to get here. And if we see that if we win the race, or if we get in this, if we pass through this, then pointer to the file is declared, then the file is opened, read right here, okay, read right here, and then it's not really printed. Another input from us is obtained, and that is printed, but not our flag. But however, the flag exists on the stack because it's read right here. So we'll see how we get it from the stack, but first we should see how we could get here to win the race. So in order to win the race, Iver should be 1 and Iver 2 should be lower than Iver 3. So those are here, Iver 2 and 3, and are the last digit or last digits of the random number generated. So in order to do this, in order to for Iver 2 to be lower than Iver 3, we need to make sure that this holds 1 digit and this holds 2 digits. So this happens where? We'll see. Iver 2 here and here. No, it's the opposite. It's here and here. So we have to get here. If we get here, so it needs to be Iver needs to be 1. And if Iver it's 1 and it gets here, then this will be true. Then the variable 2 will be lower than variable 3, because variable 2 will hold 1 digit and variable 3 will hold 2 digits, and it will always be lower. But in order to get here, we see that the variable 1 is to have the value 1, and it says here that variable 1 is 1 and variable 2 is 2. So we are gonna select 1 and 2, and let's see what this really does. So go here. Okay, this doesn't matter. Card selection, and now you're in 1, and let's go 2. Okay, and it says that we won the race and we got 100 coins. Have anything to say? And it says could not open flag.txt, please contact the creator, because I'm locally, so the flag.txt should be on the remote server, and it's getting right here because it doesn't find the file to read. But let's create the file locally first. So go let's create like here. Oh, it's, yeah, let's check it, and it's good. Okay, let's run now. And if we run right now, 1 and 2, it opened the file, and if we input something, doesn't matter why, it goes and does this. So it prints this, and then it prints what we said, so it doesn't really help us. We see here that this gets the input from us, then it reads what is in the file, but it never displays it. So let's see where this format, no, let's see where the variable stream is here. So yeah, we need to see where this is on the stack, basically, because this doesn't matter. Local 3C, and if we go back here, the man, the myth, the legend, the grand winner of the race wants the whole world to know this. Okay, so this is the format it reads, and local 3C. Let's see who is local 3C. Where is local 3C on the stack? So local 3C is basically in local 3C will be the value that is being read from the flag.txt, so basically the flag. And we see that it is at EBP, on the stack at EBP minus 38. So how can we read something from the stack? This looks this function, and then it prints the format. It reads something from here. Basically, I know there is a thing called, let's just search read from the stack bug in C. Let's see what we can find, because I know there is some input that you give to read function, and it lets you read from the stack some values from the stack, and this is what we need to do. So yeah, we can go with the debugger and see what address is on the stack, but we can't really do this because it will show the local one, and we need to see the remote one. Read from the stack. It's let's try exploit buffer stacks meshing. Read from the stack format. An arbitrary pointer stack, okay. So no, this doesn't help us. So no, it's not the formatter. Let's see, because no string formatter. There was some format that you format string attack. Okay. The format string exploit occurs when the submitted data of an input string is evaluated as a command by the application. Yes, that's right. To understand this and to understand. Okay. The format string parameter like %x and % define the type of conversion. So let's see what we need here. Do I need a table to see? No, this is x. Okay. I want to find what formatter reads from the stack. So the format string parameter defines. Okay. Oh, okay. So %x read data from the stack. So let's ready. Okay, we can also start the instance. And as it's starting, okay, it started. So let's go netcat. We'll do the same here. A. Select a car 1, 2, and then let's try C. Okay, and it gives us a memory location. But we know that in memory they are stored in little endian. So we need to convert it in big endian. So little endian to big endian converter. Need to basically convert it. Hexal. It gives us this, and hexa to ASCII, and then convert it into ASCII. So this and like this. Okay, and there are some not understandable bytes, and that is because this is not a value that we need to read more from the stack, and let's clearly see from where to where. So we saw that is at EBP minus 38. So from minus 30, from 38, basically our flag begins. So we need many more memory addresses to read from the stack. So let's read some more memory from the stack. We will do something like this. Let's do this. Okay, so what we can do, we know that in hack the box, the all the flags start with HTB. So maybe if we... Oh, okay, we can do text and hexa, HTB and this, because this is how a flag is starting in HTB. We are converting, get these bytes, go back here. It doesn't want. This will be, so it will be 7B 42 54 48. So 7B 42. Let's see if we have a 7B 42 right here. Okay, 7B 42, this should be. So if we get this from here, bring it here. Okay, it's good. And if we go and print it like this, it should be good. Oh, but it's back right now. Yeah, it's HTB. So now I think we can, so 7, it starts here, 7B, and then if we copy those like this, we can make a notepad, because we will construct the flag right here. So HTB, then we'll go get this from here, paste here. Oh, and okay, it starts showing us the flag. So we just need to, we'll make it by hand. It's no need to over engineer it by making a script or something like that. It's clearly okay. Why did 7.4, so it's this right now. I don't know if I printed enough from the stack, so maybe we'll need to make one more to be sure, but you never know. So which is it right now? 31 is this. Okay, go back here. Let's see. And the last one, I don't think we printed enough, so we'll go back. Oh, we should have counted those, so we know that it will start from minus 38, from minus 38 from EBP, because if we would have done that, it would be easier right now. Okay, so it's not enough. So why did I save the F? Okay, we will go back and let's reload the program. Let's exit. Oh, okay, it's exit right now. Let's go netcat again. Doesn't matter. 1, 2, and let's print it here. Okay, %x. So let's with a space, and now we can copy right there, and let's see. Okay, now it should be now. So F60. So now it's 66. This was the last one. Let's also get this. Go right here, copy, go back, leg. Why did I save the flag? Okay, I see where this is going. Oh, let's do it like this. Oh, it was 66, and now it's 5F 745. It's good. Get from here, copy back here, on. It's 74 was the last one. 355. Okay. On the 35. 6B. Stack. And I don't think there is another one. Think this is just the ending. So basically yeah. So this should be the entire flag. Let's see. Basically we'll go here. and let's submit it. Okay, not really that easy. Nah, not too easy. Okay, and it's accepted. So yeah, it was pretty challenging. Okay, thank you for watching.